All right, ninth period, I am very sorry that I am not here. I want to walk you through a little bit about this 1.2 Is It Right task. You also have some volunteers from your class that are ready to do that as well. So, when we were in Leaping Lizards, we talked a lot about perpendicular lines, okay? So we had a perpendicular line when we were rotating 90 degrees. We had a perpendicular bisector when we reflected the lizard across the line, okay? We know some stuff about parallel lines. We know that parallel lines have the same slope. Well, that's nice and easy. Okay, what we're trying to do in this task is learn if there is a rule for the slopes of perpendicular lines. So what you're going to do is you're going to rotate some triangles 90 degrees, and you're going to notice some things about what happens when that triangle gets rotated 90 degrees. So let's go down to experiment 1, where it says consider the points A, 2, 3, and B, 4, 7. What is the slope of this line segment? Well, to go from A to B, we are rising 4 and running 2. So the slope of that line segment is 4 over 2. You could also write that as 2 over 1. Sorry, that's a terrible 2. Or you could write it as just 2. Okay? So the first thing we need to do for our experiment is find the slope of the original line segment. Then it says to locate a third point so that the points A, B, and C form a right triangle. So there are two possible places that we could put point C. Okay, we could put point C up here at the point 2, 7, or we can put it down here. And I'm going to put my point C down here, and it's very hard to draw, so you're going to bear with me. And that's at the point 4, 3, and that is point C. Okay, so the directions for what we're going to do next are on the next page, but I'm going to walk you through what's going on here. So we're going to form this right triangle. And I know it's a right triangle because AC and BC are horizontal and vertical lines. And I know that horizontal and vertical lines are always perpendicular. They always make right angles. Okay, so what the directions ask us to do is rotate this triangle 90 degrees about the vertex point 2, 3. So what we're going to do is we're going to keep point A fixed, and we're going to rotate C and rotate B. So point C is 2 away from A horizontally. If it's rotated 90 degrees, and we're rotating 90 degrees this direction, then point C is going to rotate 90 degrees, and instead of being beside A, it's going to be on top of A. And we're going to call that C prime. Okay, so we've rotated point C. We then need to rotate B 90 degrees. Okay, and right now B is on top of C by 4 units. When we rotate it 90 degrees, that means that B is going to be beside C by 4 units. So point B prime is going to be over here, and our right triangle that looks very bad when I'm drawing it is going to look like this. And this is still point A. It never moved. Okay? So, we need to compare the slope of the rotated triangle with the slope of the pre-image. That's the original triangle. And we need to notice something about that. So the slope of the original was 4 over 2 or 2 over 1. The slope of this new triangle has a rise of 2 and a run of 4, but the slope is negative. So our new slope is negative 2 over 4. That's terrible 4. I am not as good as Khan Academy. So what do I notice? Well, I notice that the fraction got flipped from 4 over 2 to 2 over 4. And I also noticed that it went from positive to negative. So there should be 2 things that you're writing down for number 5. You should be talking about the slope flipping as well as turning from positive to negative. Okay, in your teams, you're going to complete the next 3 experiments. Okay, what you need to do is you need to draw the original right triangle. You need to rotate it 90 degrees and then tell me what the old slope was, the new slope, and what you noticed. So underneath experiment 2, I should see 3 things. I should see the slope of AB. I should see the slope of the rotated triangle, and I should see your noticings about that. You're going to complete that for experiment 2, for experiment 3, and experiment 4. Okay? Then you are going to answer this question based on experiments 1 through 4, state and observation. You are not going to answer this bottom question. You're going to leave that for us as a class. So in your teams, you need to complete experiments 2, 3, and 4. If you get those done, I have a task reflection for you that your substitute can give you. If everything else is just what you finish in class, that's okay too. Okay? Good luck.